y equals tangent of x. So from the table that we generated, I'm going to make this one a solid line over here. Solid line here, here, here. So, and then we're going to go to dotted lines and find some asymptotes. Over here, and back this way, and back this way. So if I were to plot the points that I found from my unit circle, and I were to graph y equals tangent of x, let's use a different color. This is that 0, 0? That's 0, 0. This is my x-axis, this is my y-axis, and I get this curve that kind of goes up like this, and through here like this, and then up, whoops, like this, where this is the point. This is x equals pi over 2, and this is x equals negative pi over 2. So you have asymptotes every pi over 2, and it repeats itself. It keeps going on forever and ever and ever, okay? And it keeps going, makes little squigglies. If you graph it on your graphing calculator, you might see some calculators graph the asymptotes and some calculators don't graph the asymptotes. But if you are in radian mode, let's just show you. Close. I think I must be in radian mode because I graphed that. I'm going to do y equals clear tan of x, tan x, and I am going to set my window to go from, let's do a couple cycles. So I could just put in negative 2 pi to, did I do that? Pi? Where's my pi? 2 pi to positive 2 pi. Right. Go to x min. Go to. Did I do a minus sign instead of a negative sign? That's what I did. Okay, you got to be careful with that. Make sure you're putting in a negative sign, not a minus sign. They're different in this thing. Okay, so then I'm going to go to 2 second pi, and then I have negative 4 to 4. That's good enough. And then if I hit graph, okay, you should see it makes a bunch of curves. And there's a way to make the asymptotes come in there, but in my case, they're not there. So there I just graphed y equals tangent of x, and you will have to do that on your calculator a couple times. Okay? So a couple things about y equals tangent of x. It has a domain of x is not equal to, what's x not equal to? What's x not equal to? Pi over 2. Pi over 2 plus n times pi, where n is an integer. An integer. Okay, in other words, if I add pi to this, I get this next asymptote, which is 3 pi over 2. Okay? If I subtract pi from this, okay? If I subtract pi from this, I get my next asymptote, which is at negative pi over 2. So this asymptote would be x equals 3 pi over 2. So my thing, I didn't draw it very symmetrical. These should be the same width as these two. So I messed up a little bit. But so this asymptote would be at x equals 3 pi over 2. So if I add pi to this, I get 3 pi over 2. And if I subtract pi from it, I get this one, which is at negative pi over 2. Follow that? Okay? Did I write x equals negative pi over 2? I did. Okay? Then I have zeros. Zeros are the places where it crosses the x-axis. Where are the zeros? What's that? 0. And what's this? If this is pi over 2 and this is 3 pi over 2, what's halfway in between pi over 2 and 3 pi over 2? No, it's just pi over 2 plus 3 pi over 2 is 4 pi over 2. What's which is 2 pi. So what's half of 2 pi? 1 pi, right? So this point would be pi, comma, 0, right? What? Not pi over 0. Pi, comma, 0. Pi, comma, 0. And this point over here would be negative pi, comma, 0. So that you have zeros at pi, okay, plus n times pi. Yeah? No? Maybe? Okay. We're good with that? What else? What's the range? What are the possible y values? Where is it about? What values can I have for y with my... all of them, right? So this goes from negative infinity. You could write that from negative infinity up to positive infinity. You could write y goes from negative infinity to positive infinity, or you could write it in interval notation, just like this with curly brackets on here, from negative infinity up to infinity. Okay? Oh, one more thing. What's the period? How often does it repeat itself? Unlike sine and cosine. It repeats itself every pi radians. Period is equal to pi radians. Because if you look on the unit circle, right, tangent of pi over 4 is positive 1 here. 180 degrees later, tangent of 5 pi over 4, that's equal to positive 1 as well. So the tangent of pi over 4 is equal to the tangent of 5 pi over 4. Tangent of 150 is the same as the tangent over here of, they're both negative, right? So the tangent of 150 is negative root of 3 over 3, and the tangent 180 degrees later, 330 degrees or 11 pi over 6, is also negative root of 3 over 3. Okay? So, if you're sleepy now from lunch and you don't want to take any notes or anything, what if I want to graph y equals tangent of 2x? What do you think that's going to do to my graph?
Stretch.
Not going to stretch it. Well, it's going to...
Vertical stretch.
Vertical stretch, not so much. Not going to... That's if you have a number in front. So what's the y equals tangent of 2x going to do? Yes, sir. It's going to change the period. Is it going to make the period shorter? Or is it going to make the period, is it going to stretch it this way? Or is it going to squish it this way? It's going to squish it, right? It's going to make it go 2 times as fast, all right? And so instead of, so you can think about, okay, it's going 2 times as fast. So now the asymptotes, instead of being at pi over 2 and negative pi over 2, where would they be? Where would they be? If it's going, no, that's stretching it. It would be at, no, if this was pi over 2 and it's squishing it, right? Compressing it this way.
Pi over 4.
Pi over 4. Yeah. Oh, I thought you said 4 pi. So yeah, that's pi over 4. So this is the y-axis, and this is negative pi over 4. So it's going to make your graph look the same way. It's just going to compress it. Okay. And unlike sine and cosine, with a period of 2 pi, with tangent and cotangent, the period is equal to pi. If you can't think about it that way, it's equal to pi over b, where this number here is b, right? And so if I wanted to find this, in this case, the period is equal to pi over 2, right? Which means the asymptote, since it takes pi over 2 to do 1 cycle of my function, then the asymptotes would be at negative pi over 4 and pi over 4. Yeah? Yes? Okay. And so that's what that would look like. And conversely, B, if they give you the frequency and you want to know or if you want to know the frequency from the period, you would just switch places with this and this. So B equals pi over the period. Okay, so say you have a trig function that is a period or a tan function has a period of 6, then its frequency, the number that would go in here, would be pi over 6. Okay? And so it's going very, very quick. All right, so let's do, what if I wanted to graph, so here we're going to get a little tricky on you. What if I wanted to graph y equals negative 3 tangent of 2x. 2x. How would that be different? Still has that period of pi over 2, right? Which we just did one like that. But so the asymptotes are in the same place. What's this negative going to do to it? Very good. It's going to make it come down this way, and it's going to go this way. Okay? And the other thing, instead of this being the point, if this is x equals pi over 4, then normally this point on this graph would be pi over 8, comma 1. So in this case, what would this point be? Who could tell me what that point would be? Pi over 8, comma what? What am I doing to what I plug in here? What is a 3? What do I do with a 3? What does a 3 do to it? What did it do in a parabola? What is a big number in front? Stretches it, right? So that what used to be pi over 8, 1, now becomes pi over 8, negative 3. Do you understand that? Because I'm stretching it by a factor of 3. So I'm stretching the y by a factor of 3. So this point over here would be negative pi over 8, comma, positive 3. Okay, so if I were to have this function, I would probably want you to plot this point, maybe that point, find the asymptotes so that it comes from a different direction, then do a couple cycles of that function.
Are those asymptotes supposed to be pi over 4?
Yes, I'm sorry, pi over 4. Sorry, thank you. Okay, x equals negative pi over 4. Hey,
What are those points called?
which points? These points? They're just points on the function. Okay, so they're important points, but since they curve, they're not. Are they points of inflection? No, they're not points of inflection. Where it changes from curving down to curving up, that's not a point of inflection. But these aren't, because they're just points on the curve. Okay. So now we're going to talk about the graph of cotangent, which is very similar to the graph of tangent. Are you excited about that?
Yes.
Go like this. Yes. Okay. Very good. All right. So cotangent y equals cotangent of x. It's very similar to tangent of x. And should I just tell you what it looks like, or you want to figure out what it looks like? Okay. It looks similar but different in that the asymptotes they're still the same distance apart, except it starts at, so let's go back over here. So this is the y-axis over here, this is the x-axis. Cotangent starts this way, and it comes down this way. It looks just like tangent, except it's coming from top down to bottom. Okay? And I didn't leave myself as much room to stretch it. And this is x equals pi. And then this would be x equals 2 pi. It repeats itself again every pi radians, but it's doing cycles every pi. And it starts at 0 and comes from the top. Yes, sir.
So, is it like the, oh, okay, never mind.
Because cotangent of x is equal to cosine of x, right?
Yeah.
Over sine of x. What is sine at 0? What's the sine of 0? What's the y coordinate at 0? 0. So if I plug in a 0 in here, right, I am going to get an infinite number. You understand? That's why it comes out and looks like this. So this would be pi over 2, 0, because the cosine of pi over 2 is 0, so then I get 0 over 1, you see? And that's where that point comes from. And then it has this point here at pi over 4, comma, positive 1, pi over 4, comma, positive 1, and it has this point here at 3 pi over 4, comma, negative 1. And you could get those out of plotting the graph. So a lot like tangent, it has a similar domain and range, but not exactly the same. So domain, you would have x is not equal to pi plus multiples of pi. So that's where I have my asymptotes. At x equals pi, 2 pi. At negative pi, I would have another asymptote. And I have another cotangent coming down like that, right? Okay. The what else did I have? The intercepts, x-intercepts, or the zeros, also known as the zeros. Zeros are at multiples of pi over 2. Okay. So that would be at pi over 2 plus multiples of pi. You get that? Questions about that? And what's the range of this function? Same, right? It goes from negative infinity, up to positive infinity. Do you know how to graph cotangent on your calculator? I'll show you. Okay? It's kind of, watch, all you have to do is this. If I have tangent already in there, all I have to do is take my tangent function. There is no cotangent button there. So all I have to do is take the reciprocal of that. And I could either raise that to the negative 1 power, or I could just use this little button right here. See that? X to the negative 1. So what that does, it tells it to take the reciprocal of tangent of x. And if I hit graph, look at that. That's all I had to do is change that to reciprocal. And there you go. Isn't that cool? It's amazing. Isn't that amazing?
Yes.
Okay, good. All right, so let's shift a couple of these around. What if I wanted to do, so let's get real tricky here. What if I wanted to do a shift of this function? For instance, f of x equals negative cotangent, here we're going to get really tricky, cotangent of 2x plus pi. How would I figure that out? First I want to find the shift, okay? So what is the shift? Pi over 2, right? Because it's this over this. Is it left or is it right? It's left because this is a positive number. So it's pi over 2 to the left, okay? So I'm just going to sketch a graph and then I'm going to worry about the negative sign in a second, all right? So normally its asymptotes would start here, right? But instead of that, my first asymptote is going to start here at negative pi over 2, because normally it would, the asymptote would be at the y equals 0, or x equals 0, right? So this is x equals negative pi over 2. And what's this negative going to do to it? It's going to flip it the other way. So this function would actually look a lot like a tangent function, right? Would it look exactly like a tangent function? That's wrong, because the period, what's the period of this one? 2 pi divided by 2, which is pi. So it's going to take pi radians to complete one cycle. So it's going to go from pi over 2 to where?
Pi over 2.
Wait a minute.
Negative pi over 2.
That's wrong. The period is pi over 2, because with a cotangent and tangent, they only have a period of pi. So it's going to be pi. So that's going to be equal to pi over 2. So it's going to complete one cycle in pi over 2 radians. So it's going to complete one cycle between here and the y-axis. You understand that? Okay? So it's going to come up here real fast. It's going to go up, and it's going to go like that. And it's going to do that every pi over 2 radians. So if this is y, the y-axis, this is x equals pi over 2, and so on. Do you believe me that I would be right? Do you want me to check on my calculator?
Yes.
Okay, let's check on my calculator. And so, how would I put that into my calculator? So, I gotta go always in front, always in front. And so I'm gonna go in here, and I go y equals, second, insert a negative sign, okay? And then I want to do 2x, 2, I'll just write it up, 2x, x plus pi. Should I do that? And then I want to take that whole thing and take the reciprocal of it. So what I would do is I would take the whole thing, and take the reciprocal of it. Second, insert, and put a parentheses there. And then I would take, is that what I do? Negative 10. No, I would just leave the negative over here, okay? So delete that. Delete that. Is that a negative sign or minus? You guys know? I'm going to come over here and raise this to the x to the 1 power. Let's see if that works. X to the 1. And then if I hit graph, hopefully, let's see what I get. Boom, boom, boom. Does it look like what I said it was going to look like? How would I know? I would have to trace it and make sure that around here it's at about negative pi over 2, or that at this place it's about pi over 2. Let's see. Okay, what's pi over 2 about? You guys know what pi over 2 is about? Yeah, 1 point something. Where am I? X equals 14. I don't want to be able to. It's just jumping from one. Oh, I think I have my thing. Anyway, it does look like what I said it's going to look. What if I said, find where this thing is equal to 3? Could you do that with your calculator? You'll have to do that algebraically at a later date. But could you do that with your calculator? Who can tell me how to do it with your calculator? How would I find out where this thing is equal to 3? With your calculator. How? Nah, you don't want to trace it. You want to. No, yeah, but first you have to first thing you want to do is draw the line y equals 3. Okay? And then if you hit graph, there's the line y equals 3. So there's multiple places where it's equal to 3. So you could go like this. Second calc, you go second calc, intersect. See where it says intersect? That's 5. And it will say first curve, x equals 0. So say I want this one right here, x equals 0. Let's move to, where's the first curve? First curve, I can't see where my cursor is. So right here, okay? So it'll say let's go to the next one. There we go. So say I want to know between 0 and pi or something like that, where is this thing equal to 3? Because they'll give you a domain. They'll say when x is between 0 and pi, when is cotangent, negative cotangent 2x plus pi equal to 3. So you hit first curve, and then you hit enter, and then it'll say second curve, and it'll jump up to your line. See, it says y equals 3 over here, and you hit enter, and then it'll say intersect. You guess where they intersect, okay? So the first place where this curve, where negative cotangent of 2x plus pi is equal to 3, is at about 1.4 radius, okay? And I think that would be the only place between 0 and pi, because of the next one, you're going to have an asymptote at pi. Right? Yes? You understand what I just said? And let's see if there's anything else I have to teach you. I think that's it. I'm done. Okay? So I'm gonna write your homework on the board, and it is page 300. Gosh, it's like you get. This is like worse than going to the dentist for you guys. 3, 5. It's really. I know it is. This room is hot, and I've been teaching here for 13 or 14 years. I can't remember, and I've been complaining about the heat for 13 or 14 years. So I don't think it's going to get fixed before I retire. Okay, so maybe they'll fix it the day before I retire. 36, 42, 48, 311, 42, 48, 59, and 61. Oh, I forgot 44. Sorry. 42, 44, 48, 59, and 61.
That's really short for you.
That's pretty short. And they do talk about the limits. Just one more quick little thing. What's the limit? Or they don't talk about the limit. As x goes to pi over 2, I don't think you guys know what this means. Do you know what this means? Because you're going to see, let me just explain this. In the very last problem, there's a couple things that look like this. So in this function, this says as x, it doesn't mean as x goes to negative pi over 2. It means as x approaches pi over 2 from the left side, what value does y approach? Infinity. Okay? Positive. Okay? If I did as x approaches pi over 2 from the right side, this means from the right side. It doesn't mean positive pi over 2. If I came towards this graph from the right side, what would I approach? Negative infinity. Okay, so you have a couple questions on there. The last couple of questions, just kind of conceptual questions. It's asking what's happening as I get close to these asymptotes. So I go to negative infinity, or I go to positive. Okay, and that's kind of called a limit, but we'll talk more formally about limits at the end of the year. Okay, so we're done.